In this video, we're going to take a peek at the 4 GB dataset that forms the foundation of the data pipeline that we're going to be building in this demo series. Then we're going to outline the goals and insights we actually want to achieve off the back of this data. So let's get started. So the data we're going to be using is called Land Registry data. And essentially it registers the ownership of land and property in England and Wales. So it gives information like the price has been paid, the location of the property, what style of property it is, whether it's a commercial or residential property, et cetera, et cetera. And it actually has quite a good amount of data, as you can imagine. So I think it's roughly 28 million rows. It goes back to 1995 all the way until the current month. So if we actually look at what this data looks like, well, here I am on the British government's website, and we have this price paid data, this data set, and they provide kind of a whole portal for this that we can go in and find out more about the data. But I won't go through every part of this, but what we'll see is we get monthly data. So we've got April 2023, which is the most recent month at the time of recording. And then we also have a single file which actually has the whole historical data set, which, as you can see, is over 4 GB. It's actually a little bit more than what it says here, but it's between 4 and 5 GB. So not a huge amount of data by today's standards, but still a good amount. And you generally need some more heavyweight kind of cloud processors to transfer and wrangle this type of data. Now, this data set also comes with kind of a how to use it guide, and that gives us information about the schema. So actually this data set itself doesn't have a header row. So we need to know which columns relate to what. And we have some information about each of the columns and the explanation. And particularly interesting is this record status column, which actually is only for the monthly file, but that gives us an indication of what's been added, what's been changed, what's been deleted. And as you can imagine, with regards to kind of data warehousing in our Lakehouse, we want to be able to perform upserts or mergers, if you will, where we can add the data that's new, change the data that exists but has been updated, and delete the data that needs to be deleted. So this will help us with that control flow, that logic of deleting those rows or updating those rows. If I quickly actually open up one of these files, I'm not going to open up the 4.5 GB file because that would make this video very long. But if I open up this text file, for example, and I zoom in a couple of times, you'll be able to see that we have varying kind of styles of data here. So we have just strings. So this is an interesting, unique identifier that's actually wrapped in curly braces. So we might want to do something with that further downstream. We've got numerical data, so that's just our price paid, so 243,000. Everything will be in pounds because we're talking about England and Wales here. And we've got some dates, and then we've got some normal string fields. So we've got a good amount of data here, different varying kind of data types. So this will all be really interesting and a common use case for a sample data pipeline that we're going to be building in this series. So let's take a step back though. What problems are we wanting to solve? Because in a modern data project, you want to start right to left. So you want to start with discovering the insights that you want to glean off of your data, and then work backwards to really understand what data it is you need to be able to get to those insights. Now, in this instance, the data set is not huge. It's not like we're having to trawl through loads and loads of data sets to try and find what we need and the columns that we need. It's only a relatively small data set. But oftentimes, we found this with our clients, we have a huge data estate, a huge data landscape. And starting from the data and then working towards trying to figure out what the insights is kind of the wrong way around. You need to understand what's going to benefit the business. So in our case here, again, this is just a sample. But we will want to be looking for things like spikes and anomalies. So can we attribute certain strangeness, so to speak, in our data to actual events that may have happened? And I'm thinking things like COVID in the last few years, or the recession back in 2008, other kind of like national or international events that might have had an impact on people's propensity to buy and the prices that might have that might have been paid at certain points in time. So that's one thing that we'd like to find out from this data. Now, there's also the geographical element. So this data comes with addresses of all of the places for all of the transactions that have occurred over the last 28 years or so. So we want to figure out what the regional differences are, or even on a city by city basis. So you can imagine that London, being the capital city, tends to be inflated prices compared to smaller towns, or potentially even the north of England versus the south of England. So we want to see where's cheaper to buy, or see if there's any indication of what maybe has been a fastest growing kind of property economy over the last however many years. So insights like that will be useful. And another thing that we can do pretty easily with this type of data is trend analysis. So what can we expect next year from region to region, or from property type to property type? That's going to be some interesting analysis. So that's really kind of the overview of the problem statement and the goals that we're trying to achieve with this. But let's take a look at an architecture diagram. So how will this fit into an actual fabric architecture? So if I go over to this tab here, now you can't see much of this at the moment, but this is the high level view, and I'm going to zoom in to various elements of this. So we're starting off with a fabric workspace, and that's going to be orchestrated by an end-to-end orchestration pipeline. That's just going to be a data factory pipeline that's probably going to have a few notebooks, potentially even kind of updates of data sets, for example, we will see, but also ingesting the data itself. So our data sources are going to be twofold. We're going to have the HM Land Registry data that I just showed you, but we're also going to be creating a shortcut, so a OneLake shortcut to some reference data that we've got stored in ADLS Gen 2. And we'll see how we can retrieve that data in a couple of episodes' time. But the pipeline is going to ingest that data from the web, and is going to ingest this data from the shortcut, i.e. not actually do any ingesting of data. The shortcut is essentially virtualization over an area of a data lake. So we don't really need to do anything there. But then we have this bronze zone, and hopefully you've watched the previous episode where we talked about the medallion architecture, and we talked about lake houses. So essentially the bronze zone is where we want to store the raw copy of the data, or in the case of the shortcut, we just want to store the pointer to that data in a directory structure that we specified for the bronze lake house. So actually the bronze lake house, if we remember again to the previous episode, we have our lake houses split into two areas, tables and files. The tables is going to store our managed delta tables that are generally created through Spark or a Dataflows Gen 2, for example. But we're not going to have any managed delta tables at this level. Instead, we just only care about storing those CSV files in our data lake, so that we can query them in a subsequent artifact. And that subsequent artifact is going to be a handful of notebooks. And these notebooks are going to take that data and actually transform them into the Lakehouse, where they are going to be turned into managed delta tables. So we're going to have a couple of tables, price paid data and postcode directory. So the price paid data generally coming from the HM Land Registry data that I just showed you. And then the postcode directory is going to come from that shortcut. But these are now queryable delta tables that we can perform UPSERTs on in our Lakehouse. Then the final step is to project to gold. So we want to create the house purchase projections, which means doing some dimensional modeling. So creating a star schema, so to speak. So in our gold lake house, we have our house prices, dates, locations, and property types. So that's where we've optimized for the reporting, the serving layer, so to speak. And then actually with the beauty of Direct Lake, this arrow here that goes to this semantic model, this is our Power BI data set. Those aren't actually, there's no ingestion going on there. It's just they are kind of pointed. They are, I suppose, the tables in the Power BI data set are pointed to those files directly in the lake. So we don't really need to do anything there other than the things that we care about in our semantic model, and that's the relationships between those tables, building of the measures or the calculated columns, for example, and all the semantics around, oh, what do we want to call this? This is meant to be an end consumer artifact entity. We need to make sure that the naming is as we would like it to be for people who are trying to navigate this data set or reports built off this data set and find their insights. And obviously what builds on those data sets are Power BI reports and all the associated artifacts with that, like apps, dashboards, just individual pages and visualizations. So that's our architecture. So it is a pretty standard medallion architecture. And if I zoom back out, so we see the higher level kind of colors and shapes rather than the text itself. We have our bronze area, our silver area, and our gold area, all serving different purposes, but it's helping us separate and segregate that data in different states, so that our data pipeline can be kind of manageable, maintainable, and modular, so that we can develop it over time. So that's it for this video. This has just been an introductory video to the actual problem statement, the goals that we're trying to achieve in this demo series. But stay tuned for the next episode. We're actually going to be diving into Fabric and ingesting that data from the web source. So we've got 4.3 gigabytes of data that we want to ingest into our OneLake Lakehouse. How is that going to perform? Well, figure it. You can come to the next episode and figure that one out. See you then.